Good afternoon, everybody. I want to thank you for joining us all here for today's web-based presentation, iSCSI Storage in 2010, brought to you by StarWind Software. My name is Bob Boulay. I'm one of the senior solution engineers here with StarWind Software, and I'll be taking you through today's presentation. As you can see from our agenda slide, we'll be doing the presentation in two parts. I've got some PowerPoints that I want to cover. Among the topics, obviously, are going to be covering, sort of what the traditional sand technology looks like, utilizing technologies like Fibre Channel, comparing that to iSCSI. A conversation around sand versus direct attached storage, helping you understand the benefits of sand technology, why consider a sand outside of just enabling some cool features. Why iSCSI? So assuming that you've made the decision to move towards sand, why would you consider an iSCSI type of solution and some of the benefits around iSCSI? And that'll be a reoccurring theme throughout the course of the presentation. We're going to take a closer look at iSCSI in a hypervisor, take a sort of real tight look at, in this case I've chosen Hyper-V as an example, and we're going to really take a look at what something like this would look like in production from a Visio diagram perspective, along with storage high availability and MPIO, which is something that has rolled out of StarWind in the past 6 months to really provide customers with that sort of real sort of 5 nines of availability when it comes to not only just the application layer but also the storage. The second half of the program is actually going to involve a live demo. So I'm going to walk you through, sort of putting some of this theory into practice and what this actually looks like in an actual production environment. We'll look at, sort of what's needed, how to go about setting it up, the configuration of your hardware and your operating system, and then choosing the right storage device or the right virtual storage device. As you'll see here, we've got a number of different options, and I'm going to talk you through what each one of them, the benefits of each particular storage device and where it might be appropriate. And then we'll do a review of clustered storage, StarWind HA, where we'll walk through, how to go about setting up that active, highly available storage cluster. So with that said, I want to go ahead and jump right into the meat of the presentation, and start off by reviewing sort of something that I think that we're all familiar with, sort of what the typical traditional Fibre Channel sand looks like. Now, Fibre Channel is obviously a technology that has been around for a while. Very, very, performance driven, really giving you a rock solid foundation when you do decide to move to sand. I think that, as you can see here, what we're talking about is the separation of the application layer from the storage layer. So, and this is something that we're going to discuss in just a couple more slides, but really the idea of separating those two out and managing storage as a separate entity, ultimately making the decision on what you're going to use for a backbone in order to do that. In this case here, as you can see, the Fibre Channel HBAs, a Fibre Channel switch, and then obviously your Fibre Channel storage cluster down at the bottom. Now, obviously, for those of you that have used solutions like this or worked in environments where solutions like this have been implemented, you all know that it's very robust, very performance driven, and really provides you with a solid backbone on which to go ahead and place that sort of storage layer. Now, the drawback with this, obviously, is that there's a lot of proprietary technologies that are associated with this. So we're talking about Fibre Channel HBA cards in each one of your application servers. We're talking about Fibre Channel switching technologies, Fibre Channel cabling, and then obviously the Fibre Channel sand boxes that you're going to purchase from the vendor that you choose to go with. Obviously, this is a great option for a lot of folks, but for a lot of us, we're simply priced out of that. And it's simply too expensive, and we wind up making some sacrifices in utilizing things like direct attached storage, or maybe we go all the way to the other end of the spectrum and sort of go the NAS route, where there's an option that's available to us sort of right in the middle there that's going to be cost effective and if built out correctly is going to provide us with the performance that we're looking for, and that's the iSCSI Sand. Now, the nice part about this, obviously, is that when you start talking about iSCSI technologies, you're talking about commodity hardware that's being used to put something like this together. So we're not talking about anything proprietary here, sort of off-the-shelf stuff you've probably already got in your shop to go ahead and build something like this out. As you can see here, we're talking about the standard gigabit NICs. iSCSI HBAs are an option, and for those of you that are interested in maybe exploring the differences, I'm certainly happy to discuss it one-on-one and sort of voice my opinion on the subject. But obviously, from that perspective, we're talking about gigabit networking backbone, standard gigabit switch, and really utilizing hardware that again you're already familiar with. So standard server-based hardware, server-grade hardware that you're already utilizing. You may have some in your shop now that's not being used. That can be converted into storage. And that brings up the next topic here in terms of the ability to use software to build out your SAN. And this is something that really is exciting because it really gives you the ability to go ahead and tailor a shared storage solution to meet those needs that you have from a performance perspective, but also really allow you to bring that in for a budget. So, a lot of us are faced with, sort of a binary event. We can either afford it or we can't. Whereas with iSCSI, we allow you to go ahead and pull on a number of different levers in terms of what type of equipment you're going to deploy so that you can deploy a solution that's going to fit within your budget. We can also keep an eye on things and make sure that performance is there by doing things like optimizing the networks and making sure that you've got the appropriate disk subsystem setups in the iSCSI boxes themselves. But that's the beauty of building this out with a piece of software as opposed to the traditional sort of black box approach where you unpack the thing, you plug it into a switch, and you're off to the races. This is a little bit more overhead in terms of initial setup, but really gives you the ability to customize a solution that's going to meet your needs. Now, for a lot of us, one of the things that we have to do is we have to go through the process of justifying to the business why it is that we need to go to central storage management off of direct attached storage. Now, obviously, when you start talking about why you want to consider SAN implementation, the obvious ones come to play, and they're down at the bottom there. The ability to go ahead and build out a cluster, the ability to go ahead and do some things or unlock some features of your hypervisor. But really, at a higher level, we're talking about some things that really get down to the ease of management and the more efficient management of a resource, which ultimately storage is. Storage is simply a resource that's been deployed within your IT environment or IT infrastructure. And so we want to really, the real ROI around storage is the ability to go ahead and more effectively manage that. So instead of having 5, 10, 12, 20 servers all with their own little storage pools that may or may not be being utilized to their fullest capacity, you can then take all that storage and put it in one large pool and hand it out as needed. And really sort of go through the process of taking full advantage of those storage resources. Only purchasing the storage resources that you need, without having to worry about, geez, do I need to load up a particular box with storage, only to find that application growth isn't what you thought it would be. So again, really sort of the efficient use of that resource. The other piece there is it's not listed here, but just the ease of managing storage as its own entity without having to worry about the moving parts that are associated with our applications is another large advantage. And then obviously we've got a lot of data level protection options. And again, iSCSI, particularly some of the more recent advancements in iSCSI, have unlocked that. Things like mirroring SAN volumes at the block level or volume-based snapshots are all exciting technologies here that really allow you to go ahead and offload a lot of this data protection from the application server. So no longer do you need to worry about setting up, as an example for SQL Server, a log shipping type scenario or database replication for the 30 databases you're running. You simply go through the process of setting it up for the volumes that you're using for those databases and replicate at the block level or take snapshots at the block level. Obviously, we can't ignore the application enterprise features that are associated with this as well. We all know that, in terms of, virtualization and getting to the point where you're either going to create a Zen or ESX resource cluster where you want to have the high availability option at the application level there or at the VM level, or if you want to create a cluster, a Hyper-V cluster, so that you've got some fault tolerance for your VMs. you need shared storage to be able to do things like live migration or vMotion to move VMs from host to host. Again, you need shared storage in order to be able to do that. If you don't have that shared storage or that cluster set up, you're not going to get any VM failover. And as we know, one of the downsides to virtualization is you're putting your eggs in one large basket. And so, if you can spread that risk out over several assets and make sure you've got some failover capabilities, before virtualization, if a server went down, it was generally one application that was impacted. Here, if a server goes down, it could be multiple applications that get impacted. So having that high availability option there, regardless of the hypervisor you choose to go to, is critical. Thus, you need the shared storage. You need to get away from direct attached storage. Now, this obviously brings us into a conversation around why iSCSI. Why should you choose iSCSI? And at a very high level, I think that the bottom line is much like I talked about in the earlier slides. We're going to provide a technology that is going to give you the performance that you're looking for, but at a price that you can afford. And so when you start looking at things like interoperability with universal standards, so non-proprietary technologies, that also speaks to the total cost of ownership going forward. So not only is it a scenario where you can manage it with the skill sets that you have today, you're not going out and having to hire somebody or go through a bunch of training classes to bring yourself up to speed. You're given the freedom to use the equipment that you're comfortable with. One of the things that, as many customers as I've talked to in the time that I've done this, I'm now going through a process where I'm talking to customers that really like the idea of being able to purchase the hardware from vendors that they're comfortable with. So they've already got an established relationship with Dell or HP and the type of server that they've implemented in their environment, and they can leverage discounts and really get great deals on that type of hardware. So they can now turn that into a SAN. Ultimately, we're talking about a scenario where you get all the benefits of SAN technology, with the ease of use that goes along with, really putting together a very basic setup and really giving you the performance that you're looking for. Again, architecting it correctly, putting a little bit more thought into it, and making sure that you've got this in, it's performing right and doing it at a reasonable cost. Now, I always leave this slide in, and I'm always tempted to take it out because I don't want to seem too rudimentary on these sessions. But what is iSCSI? And ultimately, we're talking about traditional SCSI commands that are going to be transmitted via TCP/IP. So in a direct attached storage situation, there's direct connectivity or communication going on to the disk subsystem through a series of SCSI commands. This is going to be basically encapsulating those into the TCP/IP packets, transmitting them via an iSCSI initiator down to the central storage box where they're unpacked, issued to the disk subsystem there, and then responded to in kind. Again, you're talking about, in the case of StarWind, iSCSI running as a service on your storage server, with your disks serving as the physical platform on top of which you're going to create your virtual storage pools. And again, the fact that it runs on commodity hardware, we're using traditional IP networks and off-the-shelf server equipment, all speak to, sort of that ease of use and that ability to go ahead and implement something like this very quickly. Now, obviously, this slide must seem redundant, but I do want to take some time to point out a couple of things here. Now, obviously, we've talked about the commodity hardware aspect of iSCSI. Again, using familiar networking standards. We do, as you're going to see, as I talk about a little later in the presentation, we do really insist on sort of network isolation in order to get this to work properly. However, the scenario that we're talking about here is really, the standard gigabit switch, versus something proprietary. The standard gigabit NICs. Things like, if you're going to make an investment into a 10 gig E backbone, that investment will stretch out and will help benefit the iSCSI implementation that you put in place as well. So that investment is not only going to impact the sort of traditional networking going on, you'll also bring to the table additional bandwidth for that storage network that you've put together. Data replication features, obviously, doing things like replicating data to a DR site, taking volume-based snapshots, which are very, very efficient in that they're just capturing the changed data blocks as opposed to snapshotting an entire volume and creating restore points based on that. And again, one of the other things that I always like to stress, which is the last point here, is the fit into a mixed environment. I always talk to folks about, sort of if you're already working with a Fibre Channel SAN or you inherited a Fibre Channel SAN, that's no reason not to consider an iSCSI solution. I think that, one of the things that you want to bear in mind is that Fibre Channel SAN may have things on it that don't need to be there. And rather than go out and expand on that and purchase more disk and more networking that's associated with that particular SAN technology, you can simply take some of the stuff that does not need to be there, implement in parallel an iSCSI SAN, and move some of the data over to that, or run some of the VMs off of that, and really get a nice mix with regard to, maybe you call it Tier 1 and Tier 2. Maybe it's something where you want to take and you need shared storage in, say, a remote office. You can certainly go ahead and deploy a SAN technology for a lot fewer dollars than you can, say, a Fibre Channel technology in a smaller remote office. Now, in terms of, iSCSI itself, it always comes up, in terms of performance. And how do I go about maximizing performance? Well, I think that, one of the first things that, and I mentioned this in the previous slide, is network isolation. So one of the things you want to bear in mind is when you configure an iSCSI network, you want to isolate that network traffic, whether it be on a separate switch or in some cases a separate set of switches, or if you want to go through and VLAN that traffic off. All of that is in play, but you certainly want to make sure that you don't have iSCSI traffic fighting for bandwidth with other traffic. Use of dedicated NICs in your application servers. So a lot of you will go through the process of setting up either multiple NICs and utilizing MPIO or teaming NICs at the driver level to go ahead and create that sort of private network for iSCSI. And obviously, a gigabit is really what we're talking about in terms of the minimum, scaling up to 10 gig if you decide to go that route. Some of the basic stuff like network optimization, making sure that you're doing things like enabling jumbo frames to make sure that you get the proper amount of network efficiency, or that the network works or operates as efficiently as possible. Some of these other items are sort of less thought of, but certainly do make a difference. Configuring your RAID set properly. A lot of us will have to make that choice. Now, if you think about how this is going to work, your iSCSI storage box will probably have either a small disk or a small RAID 1 mirror set that's going to act to host the operating system and the iSCSI service itself, with the remaining disks available to configure and serve as the physical platform for your virtual storage. So how you configure those underlying disks is going to be critical. Whether you decide to do RAID 5, RAID 10, depending on sort of the what you can afford and sort of the overhead you can afford that's associated with that, you're going to make those decisions. And then, obviously choosing the appropriate disk. So whether you're going to use, the fast SAS disks or, something that's a little less than that, maybe a SATA disk or a SCSI disk or whatnot, the drive performance obviously is going to be directly related to the performance you're going to see from the SAN network itself. The other thing that I like to talk to folks about that you have to really make sure you think through, and it can be very, very easy to make this mistake in a SAN environment where you start to sort of load up the disks and load up the SAN, sharing out bits of storage, with various servers. You need to make sure that you match RAID sets with I/O patterns. So, one of the common mistakes that I see quite a bit is, a customer will go ahead and place, maybe it's a database, set of database files on a particular SAN volume. And, it's got a very random I/O, so it's a transactional database with a very random I/O pattern. And then on the same set of spindles, they'll create a virtual storage pool for, say, a backup type of application, which is going to be very sequential. Obviously, those things are going to conflict at the physical storage level. So if you've got a lot of random I/O going on and then a lot of sequential I/O fighting for time on the disk subsystem, that's going to create a bottleneck for you. The other thing that I like to talk to folks about when you're setting something like this up is to monitor. Always need to monitor what's happening. Monitor things like disk queue length and monitor the physical disk performance. This disk subsystem, it can quickly become a bottleneck, so you need to keep an eye on it. You need to keep an eye on the load that's on the disk subsystem within your sandboxes. There's a lot of great tools out there. If you don't already have an in-house Windows monitoring tool, you can do something simple like use Perfmon, or you can go download a free product like Spotlight on Windows from Quest. But certainly there's a lot of tools out there that will allow you to do some of the basic monitoring on your SAN that will need to be done. Now, the other aspect here is around data protection. Now, this comes in a number of different flavors, and you really have to sort of think through what you need from that perspective. And then ultimately, the nice part about using things like storage virtualization is your ability to mix and match different data protection levels for different applications on the same set of sandboxes. Things like block level replication. So, if I need high availability, if my application, the primary driving factor here is high availability, I can't be down, then you can use something like a synchronous mirroring between two local boxes. That's something that I'm going to show you here with an active-active configuration where the initiator will communicate via MPIO. The other option is to do an asynchronous type of replication where you're actually going to have a primary box at your main location, and as data blocks are written to that primary location, behind the scenes that data will be replicated at the block level down to your DR site, and you'll have an exact replica of your data on your DR site. The nice part about this is it's set up to work over distances, so you can do this over a WAN or a VPN. It's very, very efficient, and that it's doing this at the block level. And obviously we talked a little bit about high availability storage. The other part of data protection here, obviously, is point-in-time snapshots. So, if you're in a situation where you've got, the redundancy within the box, you've gone out and you've bought a box that, is rock solid, you're using, say, a RAID 10 to protect against drive failures, you can utilize something like our point-in-time snapshots so that if your concern is more around data corruption or something malicious happening to the data, somebody doing something they're not supposed to, somebody deleting something they're not supposed to. With SAN technology, specifically StarWind, you're going to be able to go ahead and at set intervals that you set, you're going to be able to go ahead and capture the changes that have been made to that volume and create a restore point for yourself so that you'll be able to then go in and actually roll a volume back in the event that you need to. The other nice part about this is you can do things like file level recovery. So you can take and recreate a volume based on a snapshot, grab the files that were impacted, move those back into production, and then simply take that recovered LUN and simply blow it away. So again, a very, very easy way to go about setting something like this up. The other part of this is security. So from an iSCSI perspective, being able to lock this storage down. Things like CHAP authentication, where you're going to go ahead and put in some authentication to prevent unauthorized access at the storage level. IPsec, which is going to create some tunneling, so you can encrypt the traffic between the storage controller and the actual application host. And then things like LUN masking, so you're going to be able to go ahead and prevent the wrong application server from connecting to the wrong LUN by actually assigning a LUN to a specific application server or a specific set of application servers. And so really, giving yourself the ability to go through and lock down your storage from that perspective is really another nice feature that surrounds the iSCSI option. Now, what I wanted to do here is really sort of bring a SAN implementation and what a typical or a common scenario might look like. Now, this is pretty basic. This is not what I'd call a very complex implementation, in that obviously you could have redundant switches, and there's a number of other things that you could do here. But this shows the basics, and this is really what I want to review. As you can see here, I've got Hyper-V nodes out here, and they're clustered, and I've got all my networking set up for them. I've got a corporate network that is going to connect the VMs running on this out to the user community. I've got a heartbeat network set up for my cluster, and then I've got in red, I've got my iSCSI network set up that's connecting through my iSCSI switch, or my dedicated switch, to my storage nodes over here. Now, in this case here, I'm representing this as a high availability scenario where I've got two StarWind boxes configured in an active storage cluster, and ultimately serving up the clustered shared volumes to my my Hyper-V cluster over here. Now, a couple of things to note. Obviously we've got some dedicated networking here for the storage environment. But I've also got the StarWind HA sync channel. One of the key parts about, and if you decide to go down this road when you set up high availability storage, the synchronization channel is critical. What ends up happening, as you're going to see in the next slide, as we take a closer look at MPIO and that active storage configuration, basically your initiator got two active paths to its storage. One is through box 1 and one is through box 2. The synchronization channel is there to make sure that these two stay in sync and that no data corruption occurs. This also serves as a quasi-heartbeat so that it knows when one of the boxes is down, and the second box then becomes the lone box that's servicing I/O. And then obviously when you bring box one back up, it will not accept I/O again until you've actually done a synchronization. And the data, what'll happen is all the data that was written to node 2 while node 1 was down will be pushed over to node 1 via the synchronization channel to make sure that indeed does bring that first node that's gone offline back into into the fold. So as you can see that's kind of what something like this is going to look like in a production environment. Now, what I like to do here is sort of blow up what the MPIO and the active storage cluster is going to look like. Now, what I've got here is I've got multiple NICs coming out of my initiator node, and basically with MPIO set up here, and basically going through my dedicated switch and winding up down here, going to simultaneously writing to both nodes in my storage cluster with that synchronization channel being in between. The reason this is important, and the reason we like to really sort of emphasize this way of setting up high availability storage, what you don't have here is a simple service clustered where if one of these nodes dies, it has to wait for node 2 to spin up the iSCSI service and then start accepting I/O. This can cause a lot of I/O timeouts for applications that are very I/O intensive. Instead, what StarWind has done is StarWind has said we're going to make both nodes active. And in the MPIO driver, if you lose one of these paths to the storage, if one of the cables goes bad, the actual server goes down, whatever the case might be, where this particular application server can no longer communicate with one of these storage boxes, the I/O will just simply continue to be serviced down the remaining live path. And it will buy you time to go ahead and bring this node back up online, fix whatever the problem might be, synchronize, which would force this node to come over to node 2 and pull any data over that it's missing, and then it would start accepting active I/O again. So, again, a much better way to go about the process of setting up high availability storage. Now, obviously, this is going to, this puts a few more sort of networking requirements. In the terms of the synchronization channel, you want to make sure that's as robust as possible. In a lot of cases, you might not even want to route that traffic. You may simply want to go and plug these two servers in via a crossover cable. But if you do choose to route it, you want to go ahead and make sure you've got a team NIC there, because this synchronization channel is the key to your HA implementation. Now, with that said, what I want to do now is move over to a live environment so you can see some of this in action. I like to sort of cover the theory behind all this and then bring up the actual storage boxes themselves and sort of show you how this is configured. Now, what you're going to see here, and what I've got is sort of what you're going to see once you've downloaded and installed StarWind on a box. Now, what you're typically going to do is, again, create your small RAID 1 set, which is going to serve as the platform for your operating system and give you a spot to go ahead and install the iSCSI service. And then take the rest of the disk in this box and configure it as your iSCSI storage, the physical platform for your iSCSI storage. Once that's done, you'll then be able to go through the process of starting to create your targets. Now, that's something that I want to cover here while we're here. As you can see, I've got a number of them already set up, and I'm going to walk you through what some of these are doing. But for starters, I want to show you how to go about creating a basic target. So I've clicked on the Add Target button here, and let me bring it back there real quick. So I'm going to go ahead and select actually my local server here, which is the .149 box, and I'm going to click Add a Target. The first thing it's going to do is ask me for a target name, so we'll call this Demo 2010. And it's going to ask me what type of storage medium do I want to use in creating this target. Now, one of the nice things about StarWind is it gives you the ability to go through the process of really deciding, what type of target you want to create, and some flexibility in the core product. So, the majority of us are going to be using hard disk-based targets, which that's fine. But I also have the option of creating a target out of my optical drive. So if I have a DVD burner or something like that. I also have a tape device option. If I've got a physical tape device attached to my storage box and I want to pass it through as an iSCSI target to do things like run backups, I can do that. StarWind also offers a virtual tape scenario as well, where I can go ahead and create virtual tapes or iSCSI LUNs that will present as tapes to the application servers. In this case, I'm going to go ahead and stick with hard disk. Now, the next option you're going to have is, do I want to create a physical iSCSI target or a virtual iSCSI target? Now, here are the differences. The physical iSCSI target assumes that you're just going to take one of the physical RAID sets in your box that you've just configured and simply pass it through as an iSCSI target. Without any of the data protection features, you're just interested in creating a basic target based on a volume that you presented to Windows. That's the physical target option. The virtual targets, the basic virtual is a lot like a Microsoft virtual hard disk. It's going to be a reservation or a pool of virtual storage that's going to sit on top of or be hosted by a physical storage set within your iSCSI box. And this allows you to go ahead and essentially break up that physical bit of storage and share bits of that out with multiple applications. Then you've got your advanced virtual. This is really where we start getting into some of the more advanced data protection features that we've talked about. So whether you want to create a basic mirror device, which is really our asynchronous replication, where you're basically going to have a primary node of storage and a passive node. The primary node will service all I/O to the application servers, and then behind the scenes, the StarWind service will be replicating those changed data blocks over to a second StarWind iSCSI target that's going to act as your passive node. In the event that you get a failure of your primary node, you can simply point your initiators at the passive node and bring all of your storage or all of your applications back online. This option here does not have an automated failover piece. This is strictly asynchronous. And this is also the option that you'll use if you want to go ahead and synchronize or replicate rather your data down to a DR site. Your snapshot-enabled volumes. This, again, is the volume that's going to allow you to go through and actually create volume-based snapshots or to capture those changed data blocks and create a restore point from those. This has become a very, very popular option with a lot of customers. The reason being is that it's a nice augment to your backup strategy. If you're going through the process of backing up either virtual machines or data volumes on a regular basis, you're doing it on a nightly basis, you can then come in with this and create restore points for yourself throughout the day. So if you're servicing an application that has a very, very rigid set of guidelines in terms of the acceptance or tolerance for data loss, what you can do here is bring in a nightly backup product and then ultimately take snapshots of this particular volume and have the ability to roll that volume back in the event that something bad happens. And setting those snapshots to be, say, 30 minutes, 60 minutes, or 15 minutes apart will really be up to you. And then that retention period of how long you keep snapshots around. Now, obviously, this is nice because it's a very, very efficient way to do this. You're looking at, creating a restore point just based on those changed blocks, as opposed to every time having to have, if it's a 20 gig volume, having to have 20 gig, 20 gig, 20 gig each and every time. And then lastly, the high availability device. I'm going to walk you through the setup of this right now, and then we're actually going to go over to an application server and look at how it links up to this. But your high availability device is just that. It's basically two storage devices acting in concert with synchronous replication to provide you with a scenario where if you were to lose one of the storage boxes, or if you were to, say, have to bring it down from maintenance, or a drive goes bad, or a network card goes bad, you can simply go ahead and bring the box down, or if the box crashes, the storage will continue to be serviced via the second box in the HA set. And so this is the type of device that we're going to go through and walk through creating. Now, the first thing it's going to do is it's going to ask me for the IP address of the second storage device in my HA set. So I'm going to go ahead and plug that in. And hit next. It'll go out and do a quick check to make sure that the service is indeed running on that box. And it's telling me now that it's going to create a target out on that partner box that's just essentially the name of the target that I gave it originally, and it's going to add the word partner at the end. Now, this is the part that's pretty universal to all of the virtual storage devices. At this point, I'm going to actually make a choice around which piece of physical storage on this iSCSI box do I want to use to host my virtual storage device. So in this case, on the current server, I'll hit the file browser here, and I'll choose one of my my RAID sets. And we'll do the demo. G. And I'm going to create a new one here. And I'm going to do the same thing on the partner server. And again, I'll choose which physical volume I want to host this on. And I'm going to create a new one here as well. And I can size this volume, so I'm going to make it 256 gigs. Just a small one to demonstrate. Now, the next step here obviously is around selecting the interface that's going to be used for synchronization. Now, obviously this is, as I talked about before, a very critical factor. You're going to want to obviously have a network interface set up already, have an IP address assigned to it, and that interface should be dedicated to synchronization. And that interface can be a teamed set of team NICs, so you've got some redundancy there, or it can be a simple crossover cable so that you don't risk having to route that traffic. But either way, you need to have a valid synchronization channel, and we do recommend going through the process of dedicating that and creating some redundancy there for yourself. And then I'm going to go ahead and clear the virtual disks so I don't run into a situation where I've got obviously no data on these. They're brand new, so I simply want to clear them to get them ready for use. That's how I'm going to go ahead and initialize this HA set. And we'll go ahead and finish. And what will happen is it'll create the target down here, and it's going to go through and synchronize that target, and it's going to basically clear it out so that it's ready for use. And as you can see here, it's already finished up here, and down here it's just going to go ahead and finish up. Once that finishes, and as you can see the warning sign disappeared from that, this HA set is now ready for use. Now, once that's done, and as you can see here, I've got a number of these set up. I've got basically a couple of different types of volumes. I've got a RAID 1 device here where I've got a setup where I've got a situation where I'm replicating or asynchronously replicating data between two boxes. And then I've also got a number of these HA setups going on here. And so very, very easy to go ahead and set something like this up, whether it be asynchronous or synchronous replication. I've also got a number of these IBV volumes or snapshot-enabled volumes that have been set up here for use with my ESX boxes. So, and again, as you can see here, I've got my snapshot creation period defined. I'm doing these once a day. I'm only storing 1 day's worth of snapshots. Here's the size of the volume. And then here's the session ID, or the last session that I'm working with. This has been roughly up for almost 70 days now. So as you can see, I can mix and match the types of storage that I utilize by virtualizing the storage. And that really adds a lot of flexibility to the way I'm going to go ahead and present storage, the different types of data protection I can provide, the various data stores that I'm going to be servicing the storage up to. Now, to get a sense for what this looks like, I can bring you over to one of the ESX hosts that I've got running here, and I've got this running on a couple. Now, obviously, with ESX, you need to go through all the prerequisites to get your host ready for use with iSCSI. So you need to go ahead and make the appropriate adjustments to the firewall. You need to go ahead and create your VM kernel port, and then go ahead and enable your iSCSI initiator. Once all that's done, and you've got storage configured on your iSCSI boxes, you simply are going to come into the storage adapters and click on Properties, and through your dynamic discovery, simply plug in the IP addresses that correlate to the two iSCSI boxes that you're using in this HA configuration in this case. And it will go ahead and rescan your HBA, and it will discover all of your targets. Once your targets are discovered, you simply go ahead and come up to the storage and click Add Storage and start creating VMFS data stores out of those iSCSI targets. And as you can see here, I've got a couple of them going. If I look at this one in particular here, if I go ahead and browse or look at the properties of the data store, what I'm going to see here is multiple paths to this data store. So if I look here, I've got 166 and 151. These NICs are in the same box, and I've got my 149, which is my second box in my iSCSI HA set. So again, this is really, if I were to lose one of these boxes, let's say I were to lose this box here, these two paths would go dead, but my storage would continue to be serviced by the one remaining path. And that's really one of the real big benefits of iSCSI, is that you're able to go ahead and spread the risk out over multiple assets within your IT infrastructure. You're not putting all of your eggs in one basket. You're not creating a standard sort of target that's just you're going to hope is going to run. You're sort of insulating yourself from someone kicking the plug out of a storage box, water dripping from an air conditioning unit onto a storage box. You're going to continue to operate without an issue if you have that type of a problem. Now, on the VMware side, obviously this is pretty straightforward. And as you can see here, I've got I've rolled this IBV volume back. I've done a little bit of work with this in terms of setting this up so that I can go ahead now, and I've got a data store created that I can, if I have a problem with a VM or a set of VMs, I can simply roll this volume back to a point in time. I've also got a couple of straight sort of MPIO setups here where I've basically gone through and created a target that's hosted on a single box, but I'm using multiple IP addresses in that single box. And as you can see here, 151 and 166 are in the same on the same host. They're both on this particular host here, but I've got multiple paths to the storage here. And then ultimately, I've created, from the storage side, some redundancy, but also, if I look at a situation or a scenario like this on my 218 box, where I've got under my my networking piece here, I've got multiple NICs servicing my vSwitch as well. So I've really got some redundancy all the way down the line. Now, in the Microsoft world, it looks a little different, obviously. And then if we were to look at sort of what a cluster looks like here, I can bring up my cluster manager, and I can see that I've got a Hyper-V cluster set up with a couple of virtual machines running, a 2-node cluster with a quorum drive, and then a couple of clustered shared volumes here. Now, obviously, the key here is one of the things you need to do in preparing this type of scenario is making sure that you're configuring the MPIO role or feature on the host itself. So in 2008, Microsoft has moved this to a feature that you install on the server. So you want to install that. If you're using a 2003 box, you want to, as you install the iSCSI initiator, you want to check off Enable Multipathing. And ultimately, what happens is once you've done that, you can connect through your iSCSI initiator to your shared storage environment, and simply, what will happen is you'll plug in the IP addresses of the HA sets or the boxes in your iceGuzzi Sand, and it will present these targets. Now, in this case here, if you look closely, I've got a quorum drive here that's hosted there, and on the second box, I've got a quorum drive partner. And my quorum drive partner is here somewhere. There it is. So there's my quorum drive partner, and I've connected to both of these. So if I connect and check Enable Multipath on the partner, and then do that same thing down here on the quorum drive itself, what I'm going to wind up with is a multipath device. So basically two separate iSCSI devices being presented as a single unit, assuming I've installed my multipath driver on my Windows box. And if I look here, what I'm going to look at with the MPIO, if I look at this device, and so what I've done here is just simply gone ahead and clicked on the quorum drive, clicked on devices, and looked at the MPIO properties. What I can see here is I've got two active paths to my storage. And if I look at the details, there's the .80 path, and there's my .202 path. So again, I'm providing myself with some fault tolerance. Now, if I were to choose to use say a snapshot enabled volume, instead of multipathing that, which I certainly could do if I had multiple NICs in my storage box, the only difference would be instead of spreading it out across two boxes, I'd have a single iSCSI target, and these snapshots would take place behind the scenes, away from my application server. So I wouldn't be putting any of the pressure on my application server. I wouldn't be impacting performance of my application server in order to take snapshots of my volumes. So that's pretty much what I had in mind for the live demo portion of this. Now, what I want to do is, obviously, folks, if you do have questions, if you do, need some additional information, if you're somebody that simply just wants to talk in a little bit more detail about how this might look in your specific environment, I'd encourage you to reach out to us directly. I've provided not only our website where you can actually download either a 30-day trial of our enterprise-level software. We also offer a free version of the software as well. But I'd invite you to visit our site, and if you do have additional questions or you do want to go ahead and chat with somebody one-on-one about your situation, how to configure this in your particular environment, please feel free to reach out to us here at the number you see listed. We're more than happy to help and ready to go ahead and make sure that we get you everything you need. I really appreciate you taking the time to join us today. We do run these events on a very regular basis, so please feel free to come back and visit us again. We run them a little bit more application specific with both VMware and Hyper-V. We'll also be doing another version of this, sort of identifying it and walking you through iSCSI storage in 2010 and some of the latest and greatest features and functionality. So I really appreciate your time today, and we'll talk to everyone.